I'm not in very friendly terms with handheld microphones, so I have this thing. So I look a little bit like a hunting dog with a GPS tracker, but at least I'm not getting lost. Okay, let's get going. To a slide magically appear. Okay, my name is Tarmo. I've been working with data like last 15 years, building data warehouses, building teams that build data warehouses. And I see some trends or where the technology is moving and some best practices emerging. So I was thinking like, if I would need to build a new data warehouse right now in 2019, I would appreciate someone sharing this kind of advice, which I'm about to tell. Okay, it's been a long day for everyone. I appreciate you being here. So let's. Whoa. Can we get back? So I have a lot of very beautiful lights. It's 217 slides. So let's get going. So as I said, I've been in this business for like 15 years. And back when I was still young and beautiful, the life was really easy. So you had the source data, which was mostly relational database, Oracle or Postgre or MySQL. You had a process called ETL, extract, transform, load. It was a separate room full of people which were called ETL developers, and it was like never-ending mouse-click festival when we used graphical tools to design the transforms. And then we put all the data back to another relational database which was slightly larger, and then possibly applied some of the data transforms along the way. So it was a very nice star schema, and worked like a charm. There's not much of a trouble with that one. So life was easy. Okay, so what have changed in these 10, 15 years, other than I'm no longer young and beautiful, but just beautiful? So we have more data, much more data. I touch this point slightly later in the next slide, but data collection has been becoming much more easier. We have a much more data. What else has happened? Analysis is more complex. So if you have nothing and you run like this select and group by and some type of query, it looks like a magic, but these kind of queries get old very well, so you need to look more sophisticated analysis. And we are now structure flexible, so data is not that well structured. Again, you don't have this nice relational database with enterprise data dictionary bought from the IBM or something like that. So you have data which is semi-structured or not really structured. So how much more data we have? Some of experiences, this is from the Skype times. In 2006, we had around 100 million users, and our data warehouse was roughly 100 terabytes in size. If you compare it what's going on right now, around 1 million user is generating us like 500 terabyte data warehouse. So there are several order of magnitudes difference. So these are people, if you want to screw up really badly, you can get help from computers. So I would say around 1,000 devices, 1,000 robots can also easily create 200 terabyte of size in a data warehouse. So what's the problem there? Why can't we have more data? It means the data size has been solved for the last 5 or 10 years. You just add more computers, you have a parallel systems. If you are really rich and in working in bank, then it's Teradata. If you're not that rich, then it's, I don't know, Redshift or Greenplum, and you can just add more servers and go with it. The problem is that we have this damn law of diminishing returns. The more data you have, each additional terabyte per user is bringing you less value. It means I'm not for a moment is saying that adding more data is not a valuable thing to do, but you get diminishing returns on each additional delta you have. If you don't have anything, and again, with 100 terabyte data warehouse in Skype, it was mostly about financial transactions, so they had a lot of value. If you look at it right now, we show someone Facebook ad, which maybe someone doesn't even look at it, and we still can generate more data out of this event than someone paying $100 back. So what's the problem with that one is that if your cost grows faster than the rest of a company, when one day you discover CFO next to your desk and she's asking, how do you do? And that's a trap. She doesn't want to know how do you do. She actually don't like what you're doing. So, and my experience, like even if you have exponential growth and you think that money is for free, these things runs out in a few years, and at some point you're starting to worry about the cost. So that's one of the reasons why you cannot just approach in a more of the same, more Teradata boxes or whatever is working. Okay, so quick detour, we look what's inside the database. There is a storage. This is where your actual data is stored. There is metadata. It's data about your data. And there is a compute. It's the CPU and memory, which is processing all your data. And normally, if you look at the database, you don't think in these components because they are all in this nice monolithic form, and you don't care that they are there. You install your servers, insert your data, start querying it, and you don't care that these things are inside. But they are. And why it's important is because how we get out of a trap of a CFO standing next to a desk is we can actually split this thing into the different components, and we can start to scale them differently. Because if you can split like storage and metadata and compute, the storage is dirt cheap. And that's important because if you try to press all these hundreds of terabytes or potentially petabytes into a relational database system, it does cost a lot of money. And if you are saying that, okay, there is a huge amount of data where it's just the user behavioral data, so let's delete this and claim some 50 terabytes of the data. If you by that time had already hired some of the data scientists, it may not be safe for you to go alone to a car in a parking lot when it's dark outside, because this is what feeds their business. Because once you have done your nice Coursera courses and downloaded the data sets from Kaggle and you start to solve the real problems, you discover actually that you cannot solve your company problems with another company data. You actually need your company data to solve your company problems. And the more data is better when it comes to the machine learning. So, what happened when we split these things? Magic. Storage is cheap. We are heavily leaning on AWS, Amazon Web Services in Pipedrive on a data warehouse side. But there are other providers, whichever is a provider for you. Storing hundreds of terabytes of data is dirt cheap. It doesn't cost you too much money. You can scale the different layers differently. If you need so-called deep storage, you can store terabytes or petabytes of data, which is rarely used, and it doesn't cost you much of money. Maybe you need massive amount of compute for a very complex calculations, then you can just scale this layer of it. And also, it opens your data to a different tool sets. So if all your data is in Redshift or in Teradata, your only way to access this data is using the Redshift or Teradata, the query language, which is part of this system. You cannot mix and match and choose what are the pieces which are most suitable for your particular task at hand. So, how do we take advantage in Pipedrive? S3 is our storage. So we store all our data in S3 as a Parquet file if they are even slightly structured, and I will come to a structured data slightly later. We do use Spark as our main workhorse, and Spark cluster is installed on our own. Amazon has an offering called Elastic MapReduce EMR cluster. But 2 years ago, it was in its infancy, and it doesn't work really for me, so we have our own installation and management of a Spark cluster running on a yard. And we use PySpark to do a lot of transforming and loading. We are poking around AWS Athena, which is a pretty cool thing. It's hosted Presto engine. Anything which I say, does it make any sense? If I say Presto, do you know what Presto is? 2, 3, 4, 5 people. Okay, yeah. So it's a SQL engine developed by Facebook. What makes it magical here is that you don't need to install any server with Athena is hosted. So you pay per query, and that's actually a pretty fun thing to do, because if you have a data set which is producing like a few billion records per month, and you run this query on any normal system, when you run it for 2 weeks, it runs for 5 minutes. When you run it for a month, it runs for 10 minutes. When you run it for 3 months, it runs for 30 minutes. AWS allocates resources according to your, with Athena allocates resources according to the query size, the data size. So it doesn't matter to you query for a week or 3 months, it still runs the same amount of data roughly. You pay per data scan, so this is something which is a slightly different cost model, but still very beneficial. We use AWS SageMaker for our data science workflows, and the SageMaker can also access directly to the data, so it's not anymore locked to any particular system. And you can roll your own tool. If the data is there and you don't really understand this full Spark Athena thing, but you are really strong on R, or you don't see the data before it's loaded into the Pandas dataset, then you can also do that one. You can just load the data into your system and start using it. So it opens your tool set. So, and there are much more to come. So things we have been poking around is the same Elastic MapReduce Hadoop infrastructure clusters, which are run just one particular job and then get skilled. We can try to use GPU-based clusters for some of our machine learning and so on. So separating data from actually processing is a good thing. So then expectations again. So where should I? Okay, so that was one topic about the data size and how we can get out of a trap of data, storing data costing us too much, and data scientists killing us because we are deleting data which potentially can be very useful in the future. So the most important question is, what is a question I have been asked most during my career as a data guy? And I can give you a hint. It's not, Tarmo, can you show me how I can use analytical functions to do time series analysis of a customer behavior? I would love to answer that one. No one has ever asked me. Where is my data? I think it's strong second runner-up. Yeah, but question I have been asked most is, who is using all the resources while my query is so slow? And it's kind of fun to poke fun of analysts whose queries don't run, especially like the big boss is coming, everyone is trying to prepare the same bar charts at once, but by different organizations, or it's a month end and everyone's trying to get the numbers on what happened in last month. So problem itself is actually quite deep because ultimately it's like faulty towers, how Basil said, that I could run the best hotel in the world if there were not these damn customers. So if you build this like super nice data warehouse and it's not actually usable, it's too slow to get the data, what good it is. And what makes the workloads unpredictable is that it's a bit of a bad wording. It's not very large data sets. It's data sets in a very different size. So if you normally run queries which are maybe hit few millions of rows, and some of the queries touch the tables which are a few tens of billions of rows, then these queries require a very, very different amount of resources. Questions are becoming more complex. As I said, this bar chart doesn't cut it. There is a special case when it cuts it, when you have exponential growth. If your company grows like this, hockey sticks, no one cares what's behind it. So everyone is happy with just these bar charts. If it gets slightly more complex, growth is slowing down, people start to ask all kinds of strange questions, like in which customer segments we are growing, what are the other products these customers are using, and these questions require more sophisticated queries to find the answers. And data is for everyone, yeah? So at least here in Pipedrive, everyone can get access to the data, unless it's like, of course, privacy-related data, which you protect pretty carefully, and you start running your own queries, so you can be your own analyst. And this whole mix makes your workloads highly, highly unpredictable. So you have two choices. You build a system which either is very slow or it's very expensive. And none of them selections makes you very happy camper. This very expensive one is the same CFO comes, how do you do? And very slow analysts are deeply unhappy. So what we can do, we use dynamic scaling for resources. So I had this epiphany when I think it wasn't, unfortunately not on ABS, but I think it was Microsoft Azure back when we were still of Skype, that server is something like a paper towel. It means I used to grow up in early days when server was expensive thing and everyone guarded it and it was put to place and it used to run for 5 years and no one is allowed to touch it and it was like holy. And right now the understanding is that server is like paper towel. You take it, you use it, you throw it away and you are done with it. You can take a server for 2 minutes if you need it. And if you think about the workloads, it makes a whole lot of sense to, if the price is the same, it makes sense to gather like 100 servers for 10 minutes instead of 10 servers for 100 minutes because the cost is the same, but time is very different for acquiring. So what we do is we do on-demand scaling. Our own Spark cluster scales according to demand. This is not the perfect solution because the single query cannot easily scale. If a query is already up and running, you cannot dynamically add more servers and make the single heavy query to use more resources. But for that one, we use this paper query type of thing like Athena. There are, again, a lot of my examples are coming from Amazon products, and that's not because they are necessarily superior on anything else, but I don't have much of experience with other systems. I know that Google BigQuery has had this kind of per query type of business model for a very long time. And also, if the same time data scientists come to you and say, you know, I want 200 billion GPUs to train my models, you can carve out a separate cluster, connect to the data, which is nicely separated, and say, here, go nuts. This is all your CPUs you want and can consume, and then everything still stays together. And this is a dynamic scaling in action, what we actually have. I hope you don't see the numbers, but in idle, all our CPUs are well below 100 CPUs is used. If there is more demand, it can go up to, I think there are some safety nets. We don't want to go past 1,000 CPUs totally allocated to a cluster. But it's dynamically, if there is a bigger queue, if there is more queries, it's adding slowly servers. If the load gets down, the servers gets disallocated, and it all works very nicely. Okay, so we have solved 2 of our 3 problems. So we know how to store a lot of data without breaking the bank. How do you do? Yes, yeah. And we know how to dynamically add compute so we can handle this thing without breaking the bank. And this one you all have seen, right? There shouldn't be anyone who hasn't seen this thing. It was hilarious like 10 years ago. Until I think a few years back, I was almost literally word by word in the same situation. I was trying to check some of aggregated data in MongoDB, and I was told, like, it's not the database. You should write the MapReduce function to run it. And that introduces us to a problem that data is not the same what it used to be. Yeah? The relational database, everything was nice and beautiful. And what did Lauri said about expectations? Yeah, third time is a charm. Okay, so we have a more structure, or actually we have less structure or more structural diversity. So we all know how to handle structured data, yeah? Kimball fixed it like 600 years ago or so we know how to do it. That's not a problem. Then we have a semi-structured data, which is basically think of JSON. And that's a tricky bastard. And we also have unstructured data, which are like text, audio, videos. We don't have too much of this in Pipedrive. We do have few images, we do few sound recorded phone call transcriptions and stuff like that. But I'm not talking too much about that one. I think that if you have a good metadata about where your pictures is, where they are coming from, you should be good. The problem is with the semi-structured data, because what is a problem with a semi is that some structure kind of exists, so people expect that you can use it, you can query it, it's easy. So I have seen things which I cannot unsee. So there are JSON schema file. It means JSON, what describes the data in a JSON, which was 7,000 lines of schema descriptions. And if you see, and people say, yeah, that's data, we should be able to query that. And when these are the moments when you start contemplating important questions in your life, like what is a word, our kids are growing up, and is there a future for mankind? So there is some structure, but there is not enough structure, so data may or may not be present. There is not enough type in this one. The customer ID may be number, maybe string, maybe nil, maybe not exist at all. So for a lot of fun. I think there is some kind of hidden competition on developers, like who can invent new ways how to store data in a JSON, because I think I have seen at least 200 different ways. And okay, the question is, if you are the data guy and you're kind of responsible to pick up these kind of things and make it analyzable, so what are your options? Actually, the full principle of this one, the answer for a question is how do you solve this problem, is actually thousands of years old, and it's very well known in martial art, like Jiu-Jitsu. You don't block force with the force, you use the force against the attacker he's applying. So what we are doing is you can semi-process it. So if you get some data out of it, enough to partition the data, enough to provide some of the keys, the rest of the 7,000 attributes you can just leave as a JSON into the system, and whenever someone is coming to read it, you can say that, okay, you have all the tools, you can read it, you can define schema at the time when you are reading it. So we don't know what's inside this JSON, but look, there is a developer guy who actually produced this JSON, so you can have a nice discussion on how you can query the data, what this guy is producing, or you can as well hand out the guns and take a popcorn. So it's a thing you can do. And so you're kind of stepping out of this fight and saying, okay, this is not my circus anymore. And but you still can provide with useful tools. You still can provide store all this data. You can still provide the tools which query this data. The modern tools are very good on applying this on-demand schema when you at the moment when you need to query, they don't need to be predefined. They can profile them to get the data out, and you can do all these kind of things. Okay, so there was like 3 important problems, and we have solved all 3. Yeah, so we are good. Let's call it a day. Yeah. So there are problems. This full stack is not really very mature. So it's not like a good old relational database engine. You took the CD out of the box, you click setup.exe and next, and you have a system up and running. So it's still constantly changing. It has it's largely driven by open source, so it has all the documentation qualities of the open source, but the important information is hidden inside the pull request or bug reports and stuff like that. So you need to be able to track it or face the consequences, like this 40 pages of Java stack traces, what Lauri told you. You can outsource it. There are people who are taking this hit for a team and to provide you a working solution like Databricks or Hortonworks or Amazon EMR, but you need to pay them to be tortured. So the second one, which is getting slightly harder to implement, is the data security. Because relational database management system, everything is in a single place, the metadata is placed, the user, the ACL, everything is a single place. As soon as you separate the data and the processing power, it gets tricky to ensure that security access restrictions are followed all the way. You can secure your data, but what if the processing engine you are currently trying to use to not respect the logged in user, but tries to do some kind of system credentials to access the data, and this can be quite tricky. How do you ensure that you secure all the level so that your data is properly secured? And there is very small complexity. One thing that it's not mature. There are a lot of moving parts in a thing. So good example is like if you go to anyone and ask what is Hadoop, you don't get a reasonable answer. And for me, every time when there is something which doesn't have cannot be described in a 3 simple sentences, and you get answer like, yeah, Hadoop is not a product, it's more like an ecosystem that should send your bullshit detectors to overdrive. But that's more or less the case. So it's kind of a huge amount of different pieces working sometimes together, and you need to pick the right pieces to work together, so they are partially overlapping, so So you do use Hadoop, but you may not necessarily use HDFS. You may use Yarn, but maybe you use a system which don't like any resource manager at all, like a Presto, or you can store your data in Parquet, or maybe you can store in Orc, which are more or less the same thing, and both are Apache programs, and you keep your metadata in Hive, where there is nothing left in a Hive other than metadata store and some dialect of SQL language, and this thing goes on forever. So it's not as straightforward to implement. Okay, so what do we do in 2019? Separate storage and compute. So you can store all your data, and neither data scientist nor CFO is killing you, which is a good thing. You can provide all kind of diverse tool sets. You are not limited to SQL. You can use PySpark, you can use Scala, you can use different data mining tools, and they do not necessarily rely on any particular computing engine to provide you a solution. On-demand scaling is a thing, because it's low or expensive getting ridiculous if you need to keep all the time enough resources to handle your tens or 100 billion record tables. Yes, enable schema on read, because modeling somehow the 7,000 field JSON document is not something which we should spend our life. And problem is that one, yeah, you cannot, these arbitrary design things you cannot put into a relational database, because relational database expect that form is there before you can pour the content in. In theory, you can just store the text, but most of the system are not very good at handling these kind of scenarios. And it still enables to you, if the data is reasonable, you store them in Parquet files, you get ridiculously fast responses still. So it's not like you are building something for semi-structured data or topic scenarios, and you lose the main scenario, like how much profit we had last month. This still can be calculated. Okay, I think that was what I wanted to talk about. Do you have any questions? Nope.
There's one.
So, what are your expectations for next year?
I hope I will still be alive. So both CFO and analysts are treating me well. For us here, personally, what we are doing, or what our focus is, which I deliberately didn't even touch the topic, was a real time. So I think a lot of focus is in a Word and in a Pipedrive also moving to the real time. And I think that the real time and this kind of batch-loaded tool sets, they are currently developing in a separate track, so there is no technology which could handle both systems. So you, if you are like this kind of astronautic view and you look at the world, then the table and event stream are the same things. It's some kind of duality. Yeah? The table is accumulated changes through the events, and the event stream is changes what change the table. But when you go to the real life solutions, abstractions are not there. You need to use different system, and you probably need to mix and match them to get them going. I think Airbnb has some very, very good patterns. The Uber just last month released their system, which should do it as a single system, but I'm a little bit afraid of this promise.
You mentioned a lot about enabling others to use the compute resources that they need.
Yeah.
How do you handle the human factor there? Perhaps they don't actually need so many compute resources. Their query just sucks.
So this is roughly the question what Lauri answered. You need to accept the reality. Yeah? So yeah, with everyone's data warehouse has a risk that there is also this kind of learning factor. There are people who don't write very good queries, but as far as I can handle this load so that doesn't block everything for everyone, I think it's not that large of a cost to enable people to run their own queries. Because ultimately, if you are only creating like slow and very slow queries, you get tired very soon and go to find some other toy to do. All right. Yep, yep, so we are hiring. So if you want to be part of this mess, please find me or someone else in Pipedrive. So. Okay, thank you guys.